In this topic, we are going to learn about tree diagrams. Tree diagram is used when a random experiment involves 2 or more stages. For example, here we have 3 unbiased coins being tossed. What is the probability of getting 2 heads and 1 tail? Stage 1 represents the first coin being tossed, and we have 2 possible outcomes, being either a head or a tail. Stage 2 is when the second coin is being tossed, and we have 2 possible outcomes as well. If the first stage is a head, then the second stage can be either a head or a tail. If the first stage is a tail, the second stage can also be either a head or a tail. And for the third stage, whereby the third coin is being tossed, we will have 2 possible outcomes as well. Here it means that if the first stage is a head and the second stage is a head, then the third stage can be either a head or a tail, and likewise for the rest. In this last column here, we will put the final outcomes. After the 3 stages, we will have head, head, head here, and we will have head, head, tail here, followed by head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So the probability of getting 2 heads and 1 tail, here we have 8 possible outcomes, and therefore we have 8 here at the denominator. So how many of these outcomes are 2 heads and 1 tail? So we have 3 outcomes favoring 2 heads and 1 tail, and therefore the numerator is a 3. And the probability of getting 2 head, 1 tail is 3 over 8. What happens if we have 2 unbiased coins being tossed instead? What's the probability of getting 2 tails? Here we will have only 2 stages, and the final outcomes are head, 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 tail, tail, head, or tail, tail. The probability of getting 2 tails, the denominator here will be 4 because there's 4 possible outcomes. And how many outcomes are favorable to getting 2 tails? Well, there's only 1 of them, and therefore it is 1 over 4. In this next example, we have a bag A containing 3 balls numbered 1, 2, and 3. Bag B contains 3 balls as well, but they are numbered 4, 5, and 6. A ball is drawn at random from each of these bags. Find the probability of getting 2 prime numbers. So, how many stages do we have? We are going to draw a ball from bag A and a ball from bag B. So, there are 2 stages. For the first stage, we have 3 possible outcomes, being 1, 2, and 3, which are the numbers on the ball. And for the second stage, we will also have 3 possible outcomes, namely 4, 5, and 6. Therefore, if the first ball being drawn in bag A is 1, we can draw either 4, 5, or 6 in bag B. If the first ball being drawn in bag A is 2, for bag B, we can draw either 4, 5, or 6 as well. And if we draw the number 3 in bag A, we can also draw either 4, 5, or 6 in bag B. And the final outcomes are these. So the probability of getting 2 prime numbers is equals to the total number of possible outcomes are 9. And how many of these outcomes have 2 prime numbers? So the number of outcomes favorable to getting 2 prime numbers are 2. Therefore, the probability of getting 2 prime numbers is equals to 2 over 9. In summary, the different columns here represents the different number of stages. And each branch here represents the possible result of each stage. And for this last column here, we will write down the final outcomes. And that's all for this topic.